Hello, I will explain how to use HSPiP to develop a system of alternative methods for animal testing. First, we prepare the data for analysis. We then examine what chemical properties affect its irritancy to animal test, in this case to the eyes of rabbit. Any compound is neither poison nor medicine if it is not taken into the body nor receptors. Solubility is therefore an important indicator. Finally, I will explain how to predict substances that were not tested. In this tutorial, I will use this paper as an example for analysis. Let's try two methods of analysis, qualitative and quantitative. The qualitative analysis method predicts where the GHS category will be. The quantitative analysis method tries to analyze how many Dray's score will be. I will explain how to prepare data for the most basic HSPiP, Hansen Solubility Parameter, in practice. The first step is to collect the Cas number of the compounds. Let's do it. After launching HSPiP, first prepare a new table. Then paste the Cas number into this part of HSPiP and perform the search. When the search result is displayed, double-click this part and then this compound will be sent to the main table. Repeat this procedure for each compound. Once the main table is ready, enter the score. When using qualitative methods, we will use the GHS classification. If the HSP of the compound is close to the membrane of the eye, the compound is soluble and therefore irritating. If the compound is far from the eye membrane, the compound does not dissolve and is not irritating. This is not correct because it ignores the size of the molecule, but let's see how much can be explained by the solubility parameter value alone. Before analyzing, let me explain the similarity of HSPs. The HSP is represented by vector of three components, the dispersion term, the polarization term, and the hydrogen bonding term. When considering similarity, the distance between the vector is calculated, but unlike usual, a coefficient of 4 is added before the difference in dispersion term. Let's do it. You just set options and calculate. Great. Then you can get the sphere. The most important feature of the Hansen solubility method is that the Hansen solubility parameter of the biomembrane can be assumed. The irritancy limit is then expressed in terms of the radius of the Hansen solubility sphere. We can get eye membrane HSP as center of this sphere, and we get Hansen's dissolving sphere of radius here. we can calculate HSP distance from center to chemicals, and the HSP distance divided by sphere radius, we can get RED number. Then you check to see if the HSP vector of that compound falls inside the Hansen solubility's sphere. Let's do it. First, prepare the structural formula for SMARS and calculate it in YMB. DIY, YMB, SMARS, calculate. Then you can get HSP of this molecule. Then the new compound, calculate. You can get HSP of this molecule. Then return result to the main table. Methylpentyl ketone and glucoractone. The RED number of methylpentyl ketone is 1.03 and next one is 1.624. So these compounds are outside of the sphere. That means not irritating. Irritating compounds to the eye have similar Hansen solubility parameters. They come inside the Hansen solubility sphere. So if you want to know if they are irritating or not, you can calculate the HSP and determine if the vector comes inside the sphere. Quantitative analysis will be explained in part 2.